All right, these are the notes for 4-2, constructing arithmetic sequences. There are two types of rules that we can use to construct arithmetic sequences. The first is a recursive rule. It has the general form, given f of 1, f of n equals f of n minus 1 plus d for n is greater than or equal to 2. There's also an explicit rule, which is what we're going to deal with today. It's f of n equals f of n plus 1 plus d times n minus 1. Or, and this is the format we're going to use, f of n equals f of 0 plus dn. Okay, on examples 1 through 3, it says indicate whether each sequence is arithmetic. If so, find the common difference and write an explicit rule for the sequence. So on number 1, between -1 and 2, it's plus 3. And between 2 and -3, it's minus 5. Because those are not the same, we can stop there, and we know that this is not arithmetic. Number 2, between 14 and 12 is minus 2. 12 and 10 is minus 2. And 10 and 8 is minus 2. So two things that we need to write the rule is f of 0 and the common difference. Because the pattern is minus 2, f of 0 is 16. That's the term that happens before the first term. And the common difference is -2. So to write the rule, we're just going to substitute these in. So we have f of n equals 16 minus 2n. On number 3, from 3 to 6 is plus 3. 6 to 9 is plus 3. And 9 to 27 is plus 18. So that is not arithmetic. For examples 4, 5, and 6, we're just going to write an explicit rule for each sequence. If the directions just say to write the rule, you can go ahead and assume that it is for sure an arithmetic sequence. So we need two things for that. We need the f of 0 and the common difference. So for this one, the common difference is 5, which makes f of 0 -10. So f of n equals -10 plus 5n. For 5, the common difference for this one is -3, which makes f of 0 10. So f of n equals 10 minus 3n. For number 6, the common difference is 3, which makes f of 0 1. So f of n equals 1 plus 3n. Okay, and we're not going to use explicit or examples 7 through 9. Okay, in the extra notes, writing a rule for the nth term, which is writing the explicit rule. So we're going to write a rule, and then we're going to find f of 12, so the 12th term in the sequence. When this one has 11 halves, 25 6, 17 6, 3 halves, and 1 sixth. To make it easier, you should probably change the denominator of 2 to 6. So the first one is 33 sixths, and then 3 halves is 9 sixths. This will make it a little bit easier to use. We still need the common difference, and the common difference in this is negative 8 sixths, which simplifies to negative 4 thirds. And f of 0 is going to be 41 sixths. So we did 33 and added the 8 sixths to it and got 41 sixths. So my rule is f of n equals. Now when you write the rule, you have to use the simplified numbers. So we're going to say 41 6 minus 4 thirds n. And that's our explicit rule. Now when you go to solve, if you want to use the 8 6 because that's going to be easier, that is okay. So if I want to find f of 12, I have 41 6 minus 4 thirds times 12. And actually here I would change this to 8 6 times 12. Because the denominators, to add and subtract, we have to have a common denominator. So this becomes 41 6 minus 96 6. 8 times 12 is 96. So f of 12 equals negative 55 6. In example number 2, it's 0.1, 2.4, 4.7, 7, and 9.3. The common difference for the sequence is 2.3, and f of 0 is negative 2.2. So when I write my rule, it will be f of n equals negative 2.2 plus 2.3 n. Okay, f of 12, you just substitute the 12 in, so you have negative 2.2 plus 2.3 times 12. So negative 2.2 plus 27.6. So f of 12 equals 25.4. Okay, you'll also need to graph sequences. They've given us a sequence of f of n equals negative 3 plus 5n. You're going to go ahead and just substitute numbers in. Keep them small, and I would keep them positive also in this case. So we'll say f of 1 is negative 3 plus 5 times 1, which is going to give us 2. F of 2 is negative 3 plus 5 times 2, which is 7. F of 3, negative 3 plus 5 times 3, which is 12. F of 4 is negative 3 plus 5 times 4, which is 17. Okay, your ordered pairs, it's your input and output. So it's 1, 2, 2, 7, 3, 12, for 17. So I have 1, 2, 2, 7, 3, 12, 4, 17. Because these are specific points, excuse me, sequences don't include every point in between, so do not connect the dots. Also, you need to use at least 3 points on each graph. You can use more, like I used 4, but you have to have at least 3. The last thing I'm going to leave you with is a word problem hint for your homework tonight. You're going to want to write out the sequence of numbers that are described in the problem. Once you do that, you should be able to write an explicit rule and then answer any questions that are asked of you.